morning students. Today we are going to the lecture number 5, central tendency and dispersion. We will continue what we have stopped from the previous lecture. What we are going to see today is one important property of a normal distribution, and second we will see various kurtosis, then after that we will see the box and Whisker plots. That are also different way of measuring the dispersion. You see, there is an empirical rule if the histogram is bell shaped. Look at this normal distribution or bell shaped curve. This yellow line says that from the mean, if you travel either side on 1 sigma distance, you can cover 68% of all observations. Come to the second one, from the mean 0, if you travel 2 sigma distance on either side, you can cover 95% of all observations. The third one, if you travel 3 sigma distance on either side from the mean of a normal distribution, you can cover 99.7% of all observations. This is very important empirical rule. Even though we will study in detail about the normal distribution and its properties in coming lectures, I wanted to say this idea. It may be very useful in coming lectures, because we can say the normal distribution is the father of all the distributions, because if you have any doubt on nature of the distributions, if you are not any sure about what distribution the data follow, you can assume normal distribution. But there is a limitation of this empirical rule. It is applicable only for the bell shaped curves. There may be a situation the actual phenomena need not follow bell shaped curve. At that time this formula, that is this empirical rule, will not work. So, we will go to another rule. I will see next slides the same thing what I given in the previous slides. See, mu plus or minus 1 sigma, you can cover 68% of the all observations. Mu plus or minus 2 sigma, you can cover 95% of the all observations. Mu plus or minus 3 sigma, you can cover 99.7% of all observations. Actually this 1, 2, 3, it is nothing but Z. I will tell you in coming classes what is Z it is. Okay. The previously we have seen that the properties of normal distribution, that is a bell shaped curve. Sometimes certain phenomena need not follow the bell shaped curve. That time you cannot use that property which you have studied previously. We have to go for another formula to find out how much observations are covering under 1 sigma, 2 sigma, 3 sigma distance. This idea was given by Chebyshev. It is called the Chebyshev theorem. A more general interpretation of the standard deviation is derived from Chebyshev's theorem, which applies to all shape of the histogram, not just bell shaped. The previously which you have seen, what is only for bell shaped, but here it is applied, it is applicable all shape of the histogram, even the distribution can follow any shape. So, the proportion of observation in any sample that lie within k standard deviation from the mean is at least 1 minus 1 by k square. So, how to read this formula is, suppose a phenomena which is not following normal distribution, if you want to know at the 2 sigma distance how much percentage of observation can be covered. So, when you substitute your 1 minus 1 by k equal to 2, 1 minus 1 by 4, so it is 3 by 4. So, 3 by 4 means 75%. So, if you travel 2 sigma distance on either side for a distribution which is not following normal distribution, you can cover 75% of all observations. You see, the previously it is 95%. So, you see that what is given for k equal to 2, the theorem states that at least 3/4 of all observations lie within 2 standard deviation of the mean. This is lower bound compared to empirical rule approximation 95%. In case of the previous slide, if it is a 2, we can cover 95% of all observations, but here we can cover only 75% of all observations. Sometime we can use Chebyshev theorem also if the data is not following normal distribution. These two properties in coming classes many times we will refer that 1 sigma, 2 sigma, 3 sigma. Just I thought I want to give an idea about the normal distribution, but we will go in detail later. The next way to measure the dispersion is coefficient of variation. The ratio of standard deviation to the mean expressed as percentage. So, coefficient of variation is your sigma by mu. It is the measurement of relative dispersion. Already there is a standard deviation is there. Then what is the purpose of this coefficient of variations? That we will see the next slide. Look at this. You say stock A, stock B, or stock 1 and stock 2. The mu is 29, sigma 1 is 4.6. The another one mu 2 equal to 84, sigma 2 is 10. Suppose if you want to choose which is better, if you compare only the mean 29 versus 84, the second stock is better. Suppose if you compare the standard deviation 4.6 and 10, the lower the standard deviation better it is, so the stock 1 is better. Now there is a contradiction. With respect to mean, option B is better, with respect to standard deviation, option A is better. Now there is a contradiction, so you need to have the trade off. In these situations, we have to go for this coefficient of variation. Coefficient of variation is your sigma 1 divided by mu. For example, for this case it is a 4.6 divided by 29 multiplied by 100, 15.86. For second case it is sigma 2 by mu 2, 10 divided by 84 multiplied by 100, 11.9. Lower the coefficient of variation, better the option is. So, if the coefficient variance is smaller, we have to choose that group or that stock. Now, we will see how to find the variance and standard deviation of the grouped data. Already we have seen standard deviation of raw data, this is ungrouped data. We have seen standard deviation for population, standard deviation for sample. Similarly, we will find the variance for grouped data. So, the formula is sigma f into m minus mu whole square divided by n. Here f is the frequency, m is the midpoint of that interval, mu is the mean of the interval, n is sum of all frequencies. For the sample variance, look at the formula, here also it is n minus 1. So, sigma f m minus x bar by whole square divided by n minus 1. So, we will see this example. Now, look at this, now the grouped data is given, nothing but the problem is given in the form of table. So, you see these are the interval, these are frequencies. So, 20 to 30 there are 6 values is there, between 30 and 40 there are 18 values is there, 40 and 50 11 is there, 50 and 60 11 is there, 60 and 70 3 is there and so on. So, first one we have to find the midpoint of the interval between 20 and 30, the midpoint is 25, 35, next interval 45, 55, 65, 75. Now, you multiply this f and the midpoint of the interval. So, 150, 630 and so on. We need this sigma fm, then you can find m minus mu. M is 25 minus 43 minus 18, 35 minus 43 minus 8 and so on, then you square it, then the squared value you multiply by f, you are getting this f into m minus mu whole square. When you add it, that is going to be 7200, n is sigma of f, that is nothing but 50. So, 144 is the population variance of this grouped data. If I want to know the standard deviation of this grouped data, just to take the square root of the variance, that is 12. The next measure is shape of the, we can say, set of data, that is shape or distribution, what distribution follows. We can see the skewness, kurtosis, box and whisker plot, there are 3 methods. So, we will see what is the skewness. Skewness is the absence of symmetry. As I told you, it may be, see this is left skewed data, this is right skewed data, this is symmetric data. So, this absence of symmetry, this and this can be done with help of skewness. So, the other one, the application of skewness is to find out what is the nature of this shape, whether it is skewed or symmetric. Next one is a kurtosis, it is the piquetness of the distribution. There are three ways. There is one leptokurtic, mesokurtic, platykurtic. It is a leptokurtic means high and thin, it will be like this. Mesokurtic is little flat this way. Platykurtic is very flat that way, flat and spread out. Then we can see box and whisker plot. It is a graphic display of distribution. It reveals a skewness. The application of box and whisker plot is to check whether the data follow a symmetry or what is the nature of the skewness of the distribution. We will see one by one. See the skewness, left one which is in orange color, it is the negatively skewed. As I told in the previous lectures, the skewness is, how it is named is looking at the tail. The tail is on the left hand side. So, it is left skewed or negatively skewed. Come to the blue one, extreme right, it is this tail is on the right hand side. So, it is right skewed or positively skewed. The middle one there is no skewness, so it is symmetric. The skewness of a distribution is measured by comparing the relative position of the mean, median and mode. If the distribution is symmetrical, we can say mean equal to median equal to mode. If the distribution is skewed right, the median lies between mode and mean and the mode is less than the mean. The distribution is skewed right means this way, skewed right means this way. So, this will be our mean, this will be our median, this will be mode. Look at this, median lies between mode and mean, the mode is less than the mean because mode is less than the mean. The same thing, the distribution is skewed left, this is the case, skewed left. So, the mean position of mean will be here, median position of mode. The median is lie between mode and mean and the mode is greater than the mean. As I told you, whenever if you want to know the central tendency of a distribution, you have to check the nature of the distribution. If it is a skewed right or left, you should go for median because the median always middle of the distribution irrespective of its skewness. The same thing what I have explained the previous one, mean. See negatively skewed, the position of mean is here, median mode. Positively skewed, the position of mean is here, median is here, mode is here. There is no skewness in the middle one. How to find coefficient of skewness? The summary measure of skewness can be measured as S equal to 3 into mu minus median divided by sigma. If S is negative, it is negatively skewed. If S equal to 0, it is symmetric. If S is greater than 0, the distribution is positively skewed. Okay, we will see an example. Mu 1 is 23, median is 26, sigma 1 is 12.3. When you apply this formula, 3 into 23 minus 26 divided by 12.3, we are getting negative. So, it is negatively skewed. Go to the middle one, mu 2 equal to 26, median equal to 26. So, 26, it will become 0. So, S2 equal to 0, that means for this distribution the skewness 0, so it is symmetric. The right one, mu 3 equal to 29, median is 26, sigma 3 is 12.3. When you substitute here, we are getting positive value of S3, so the skewness is positive. The kurtosis, as I told you, it is a pickedness of a distribution. When I say leptokurtic, this one, leptokurtic. So, it is high and thin. If that means it is a highly homogeneous distribution, the things are very close. This is second one is a mesokurtic, normal shape. The last one is platykurtic, flat and spread out. The next one we will go to box and whisker plot. There are 5 positions in the box and whisker plot. One is median Q2, first quartile Q1, third quartile Q3. The next one is the minimum value in the data set, maximum value in the data set. We will see this one, yeah, this one. So, this point is our minimum value. In this box, it is a Q1 is the quartile 1, quartile 2, quartile 3 maximum. Why it is called box and whisker plot? The whisker, it is looking like a whisker of a cat, you know. So, it is a box and whisker plot. You see how the skewness can be measured or identified with the help of box and whisker plot. So, by looking at the position of this middle, this line, we can identify the distribution. What is that? If it is on the right side of this box, it is left skewed data. If it is left side, it is right skewed data. If it is exactly on the middle, it is symmetric, which follow normal distribution. So far we have given some kind of theories about these various central tendencies and dispersions. Now I am going to switch over to Python. So whatever we have done, the theory portion, whatever we have taught here, so I am going to use Python. I am going to explain how to use Python to get central tendencies, skewness, box and whisker plot, and various dispersion techniques with the help of Python. So we will go to the Python mode now. Okay, now we have come to the Python environment. The first, as I told you, we have to import pandas as PD. We can use this PD is for only our convenient. Pandas is a library. Then you have to import NumPy, numerical Python, as NP. Okay. So the first one is to import the required libraries. The second one, I am going to import the data set. So the data set, already I know the path of the data set is otherwise the name of the data set is IBM underscore 313 marks.xlsx. So I am going to save in the object called table equal to pd dot, this is the command, this read underscore excel is the command for reading the Excel file. The path is this colon IBM -313, otherwise simply you can type it there. Now print table, let us see what is the data. So you look at this, serial number is there, MTE, that is a midterm examination marks, mini project total, end term examination marks, and total marks. Okay. This total is out of 100, this total is out of 50. You see it is starting from 0, 1, 2, 3. Okay. Now I want to find out the mean of the total, that is in the end term examinations. So x equal to table, that is the object name, there should be a square bracket, there you have to write the column name in the quote. So that means I am going to take only the column name total and I am going to store that value into a variable x. Now the x is nothing but the last column. If I want to know mean of that one, so np dot mean. Otherwise if you want to know np dot, if you press tab you will get various options. Do that, np dot tab. See here there are so many options there, in that there are maximum, minimum, mean, median. You need not remember, also you can check it one by one. So now we will go to the np.mean, then np.mean, then we will call that variable x, we will execute it, shift enter. So we are getting this value 46.90 is the average marks, that is the mean. We will go to the median. So np.median, median is 45. We will go for mode. The mode you have to import scipy. From scipy import stats, stats is the another library function. So stats.mode, call that variable x, we will see what is the mode. Mode is the number of frequencies. Suppose there are 5 students, say got the same 30 marks, the mode will be 30. Okay. So okay, we will come back to later. So next we will go to percentile. In percentile, suppose I have taken a array, you see that we are introducing another one, np dot array. So a equal to np dot array, just we have taken an array 1 2 3 4 5. Suppose I am going to say p equal to np dot percentile of that array A 50. Suppose what I wanted to know? I want to know 50th percentile. 50th percentile means what value in this array will be the 50th percentile. So, when I execute this print P, so 3 is the 50th percentile, nothing but the median. This number is very small number for illustration purpose. So, you can have a large number, then you can run it. Then now we will go to the another command in Python is the for loop. For loop is, suppose I have taken a variable k, I have saved 3 variables. One is ROM, see the character should be in the code 65 2.5. Suppose if I print k, what will happen? You see that it is printing ROM 65 2.5. But there is a requirement that I have to print one by one. First I have to print ROM, then I have to print 65, then print 2.5. Now here at a time I am getting all the answer, but I want to print one by one. So for that purpose, see that for I in k, this is the syntax, there should be a colon, that is one. Print I. So what will happen? First in k, this is array. So first for I in k, first the I will take the value of ROM, second I will take the value of 65, third I will take the value of 2.5. Now if I execute this print I, you see that one by one. So this is the one by one I am getting this output. So this is the example of for loop. So for I in k, the k is in which variable. So the I value will change. So if you want to print I, so this the first it will print ROM, then 65 and 2.5. Because why I am showing that, we are going to use this for loop in coming examples. So I want to give an idea about how to use for loop in Python. Now we will go to range. So for I in range, you see that 10, 20, 2, this is the range function. The range, first one is the starting value, the second one is says the ending value, the 2 is increment, colon, print I. If I print that, you see that, now what is happening? 10, 12, 14, 16, 18 incremented by 2, ending with excluding 20, 1, 2, 3, 4, 5, increment is by 2. Now suppose in the print I want to print, now it is printed one by one, but I want to print in a with a comma. So 10, 12, 14, for that purpose the same command, the I you have to use end equal to, it should be separated by comma in colon. So if I run this, what is happening? See 10, 12, 14, 16, 18. So this one, so end equal to in colon comma, that is what how it is giving the output in a horizontal way. Now we will go to the next option, functions in Python. Suppose the functions is very useful applications in Python many time, because there are some built-in function is there. For example, print is the built-in function, maximum is the built-in function, minimum is the built-in function. You can create your own functions, then you can call that function wherever it is required. Suppose def, that is the syntax, def greet, see open parenthesis, end with the colon, print hi, print good evening. So this is the way of defining a function. Okay. Then after defining the function, you have to call that function. Suppose I called greet, I will execute this, what is happening? So this function is getting executed, so I am getting hi and good evening. So another example of a function, suppose I want to add two numbers. So def, that function name is add, in parenthesis p comma q, it can be anything colon, but the colon is important, otherwise it will go syntax error. So c equal to p plus q, so print c. Suppose this is my function, suppose this is, I am going to call this function add 6 comma 4, what answer I am getting? Suppose some other number, suppose add 10 comma 4, so I am getting 14. We have seen how to create a function. Now finding the minimum maximum value in the data set. Suppose I have created a new array, data equal to 1, 3 and so on, 4, 6, 3, 2, 6, just I have taken randomly. Suppose I want to see the minimum value in this array and maximum value in this array. So what is happening? So, minimum value is 1, the maximum value is 463. So, for that the command is min and max. Now, this minimum and maximum value I can create own function, then I can call that function, because every time I need not type minimum, min data, max data, because already that was built in function. I can create my own function. So, the same data I have taken 1, 3, 4 and this one. So, I am defining function name min underscore and underscore max data. So, min underscore value equal to minimum of data, maximum underscore value equal to maximum of data. Now, return, because I want to get the output. This is indentation is more important. Suppose there is no def minimum underscore value should be the same indentation. Generally, you can give a tab. Tab means we can say 4 space bar. So, return underscore minimum underscore value, maximum underscore value. We will run it, let us see what is happening. Shift enter. So, I am getting this because I called this function again. How? Min underscore and max data, because the function name is min underscore max. So, 1 comma 463. So, this functions application is very much useful in Python, because when you are making a large program, every time some routine aspects you need not do it yourself every time. So, you can call that function whenever it is required. It will save a lot of our time and energy. So, now suppose I want to know the range of the data. Range is nothing but maximum value and minimum value. For that I go to define a function def, that function name is range f, that is the range f I given, you can give any name for the data. So, how I am finding minimum value equal to min of data, maximum value equal to max of data, return maximum underscore value minus minimum underscore value. So, if I call that function range f data, what will happen? I am getting 462, is nothing but 463 minus 1. Now, we will go to quartile. Quartile we have seen already, it is a Q1, Q2, Q3. Q1 is the 25th percentile. So, there is an inbuilt function in NumPy. So, when you say A, I am creating an array, A equal to np dot array 1, 2, 3, 4, 5. So, Q1 equal to np dot percentile. This np dot percentile will give you the percentile. Suppose if I want to know 25th percentile, I can get what value in this array is a 25th percentile. So, if I execute this, so 2, that means the value in 2 is 25th percentile. So, the same thing np dot percentile a comma 50, if I put, I am going to call it as Q2. So, 3 is the otherwise median. You see, look at this, because it is the odd number, the middle value is 3, obviously it is the 50th percentile. We will go for third one, Q3, it is a 4, that is the 75th percentile. Next, the spreadness is measured in terms of interquartile range, as we know already Q3 minus Q1. So, that is nothing but IQ. So, if we see IQ, that is nothing but Q3 minus 1 to 2 is interquartile range. Now, we will go for how to find out the variance. Suppose there are two variance. One variance is for find variance of mean, another one is the variance of the population. If when you put np dot in NumPy var, it is for the population variance x. So, what is the x? X is x is the total. So, that column, the total column, we have saved in the name of object called x or variable called x. So, we will see. So, variance is 262.782. Suppose there is another function, we have to import a library statistics. So, statistics dot stdev, that is a population standard deviation x. So, I can get the population standard deviation, that is 16 point, it is the standard deviation. So, if you want to know the standard deviation of the sample, so statistics dot stdev. So, only thing is, if you want to know the population standard deviation, you should write p there, p stdev. Otherwise, by default in statistics library, you are getting only the sample standard deviation. This is standard deviation for the population, this is standard deviation for the sample. Next we will find the skewness. For that you have to import SciPy. From SciPy there is a library called .stats, import skew. So, skewness of x. So, skewness is positive value, so it is a right skewed data. Next we will go to box and Whisker plot, because for drawing plots you have to use matplotlib, import pyplot as plt. So, plt dot box plot, there is a inbuilt function is there, x comma symbol is star, plt dot show, execute this. So, we are getting box and Whisker plot. You see that box and Whisker plot, there are some star symbol that implies that data are outlier. Outlier means which goes beyond maximum value and beyond minimum value. The position of this middle line will help you to identify the nature of the distribution. If it is the left side, it is right skewed data. See, look at this, because right skewed positively skewed data. Now it is little left side. So, the data is right skewed data. So, with that we are stopping this central tendency. So, what we have seen so far, we have seen various central tendencies and different way of measuring the dispersions. Whatever you learnt in theory part, that we run in Python, we got the answer. There are so many sources are available in internet to know the different codes, different way of find out. You can also refer that for this class. Thank you.